All right, hello physics people. Got another crazy problem for you. So this one, we're starting to learn how to track the motion of things. In this case, we have two particles, one starting from different locations. They're going to be moving in some manner, and after a certain amount of time, we want to know where they each are. Okay. So first things first, let's draw a picture. So they say that particle one is at the origin. So here's 1, and then here's my origin. And then they tell us that it's moving left to right. So then I will define, this will be my positive x direction here. Okay. Now it says particle 1 starts from the origin with an initial velocity of 12 meters per second. Okay. And then they say particle 2 starts its motion 22 meters ahead of particle 1, so it's kind of got a head start. And this one is moving with a velocity of 9 meters per second. So this one's moving slower, but it starts out in front. So after 10 seconds, we want to know which one's in front. Which in front? Okay. So after 10 seconds, which one is in front? So really, this comes down to being a kinematics problem. If I can express the position of each of these, of particle 1 and particle 2, as a function of time, then I can evaluate where this thing is at 10 seconds and easily see which one's in front. So x1 as a function of time. Well, the general equation for an object moving with velocity and zero acceleration is just going to be x naught plus v naught t. It's just the general equation, not using any numbers yet. So for particle 1, it starts at x equals 0, and it's moving to the right with a positive velocity of 12 meters per second, and then I still have a t left over. So this is 12t. Similarly, you'll get the same general equation for particle 2, but particle 2 starts 22 meters in front and moves with a velocity of 9. So we have 9t. So now I can say, what is x1 evaluated at 10 seconds? Well, that's just 12 times 10 equals 120 meters, right? Because we had meters per second times seconds. So those cancel out, so we're left with meters. So now I can do x2 evaluated at 10. I'll get 22 plus 9 times 10. That is 112 meters. So at 10 seconds, particle 1 is in front by 8 meters. Okay, and that's our problem. So it just comes down to using our kinematics. And remember, for these ones, there's no acceleration. So the most general constant acceleration I can write function I can write for the position would be x naught plus v naught t plus at squared over 2. In this case, the acceleration of each of these particles is 0, so we're just left with x naught plus v naught t. And then it's just a matter of plugging things in.